Okay, so let us start with afternoon session. So it's we will have a short talk now about I hope less than half an hour, but the idea is to after the talk we go outside and to the park and test the app. Yeah, so it's basically within Open Earth Monitor project we are developing the mobile app. It's not only within Open Earth Monitor, but we also have another funding, the national funding from Austria, and another project, Citizens for Copernicus. It's about citizen science data, so crowdsourced data to support modeling with with Copernicus satellite images. And Florian, my colleague Florian, is also today with me. So we together work on developing this app, testing it intensively. Florian is expert in ecology. Yes, and but also he's one of the rare persons who done the laser scanning in tropics, which is amazing. So he surveyed, I think in Costa Rica, he's I would say the best laser scanning guy surveyor in Costa Rica. He has amazing TLS data set there collected, and so also with remote sensing Earth observation links. Yeah, so thanks Florian for coming today. So we will together go and try to test the app there. And of course, Florian is also behind designing all these experiments, the reference data, how we collect this, and how we calibrate the app. So yeah, I don't know if somebody, maybe Giuseppe, if you can just allow people to access the meeting, because I hear I'm not sure if, because I'm not sure I can do this, or somebody else. If you see that we have participants entering the meeting, just let them in. Yeah, thanks. Good. Yeah. So citizen science mobile app for measuring trees and forests. This is what we are developing now. But before jumping on that background on the group we are working on, it's novel data ecosystem for sustainability nodes. And so our focus is citizen science, so like trying to advance the citizen science, enriching Earth observation, and exploiting the digital revolution. Those are kind of, let's say, tracks we try to stay on. And what we are practically very known is the GeoWiki platform. This is, let's say, the web platform where one can design a citizen science campaign with remote sensing, with satellite data in the background. As you can see here, you can get like time series. Here you can set up like a questionnaire, and then you can design the campaign. So like some random points where people can mute other people in a meeting. Yeah. Thanks. So you can ask. Then basically there is a questionnaire. People are they visit the sites, they examine, and they made the decision. So it's possible to collect the reference, or let's say citizen science data, crowdsourced data for that are relevant for land money. So for land mapping and many other applications. This is one thing. Another thing is also we are developing a lot of mobile apps applications. So as you can see here, again, citizen science. So here is like about how the area is wealthy. So it's actually a street view from Google Maps, and then the user can just use the phone and say, I go to the right is very poor, I go to the left is very rich, and so it's very addictive. When you start doing this, so you can provide a lot of a lot of approximate data with a different quality. This is all citizen science, and then those data are, it's actually just alternative way of collecting some reference data for satellite images. Yeah, about the background of the app that we are now developing, it's like this is a global carbon budget, and we have several stocks: oceans, land, atmosphere, and this is all fine. But we also have those uncertainties next to those stocks and fluxes. Yeah, and those uncertainties, this is the biggest challenge now, to minimize them so they are still large enough. So and there are different approaches to assess the carbon stocks around. So through the traditional ways, bookkeeping methods, and in situ data, and there is an Earth observation approach. Yeah, but of course, with Earth observation approach, we need in situ data to calibrate our observations and bring them to reality. So basically, more information on carbon stock, on biomass is necessary. So that was our main motivation. And as you can see here, so there are different approaches how one can map the biomass. Half of the biomass is carbon, and so there are different satellite observations, and you can see they can be combined. Then there is a kind of a model, and then we can do wall-to-wall predictions. Yeah, but to combine them with those point data, with those, we call it in situ data, we need to have in situ data. And a lot of the forest inventories, they are not open data. Most of the inventory data are not shared, they are not open. And so basically it's very hard to get such kind of data to create those models that will enable wall-to-wall mapping of the biomass and carbon. So that's why we decided to put our efforts on developing the mobile app that will actually, in a way, democratize those in situ forestry data. So we are not. Our goal is not to compete with foresters and provide more accurate data. That's not possible. The forestry in situ data are, let's say, well organized and very maintained, good maintained and planned data set, sampling, very systematically collected data, so and very reliable data set, but it's also very costly, and it's not open. So we are just trying to with those projects and initiatives to see how citizen science and how the crowdsourced data can complement existing data, and what we really can get from citizen science data. So aside this caveat, so our main aim is basically to replicate all the measurements that are done in a forestry with a mobile app. So that's the goal. To do that, we developed this app. It's called GeoQuest. And you can see here we have different modules. We have a Forest Quest and Tree Quest. Forest Quest is a mobile app that mimics the Bitterlich method. So this is a kind of forestry method where you can get some area, some estimate of the basal area inside of the forest. So it's like just cross section of the stem volume, and then with the height you get the volume, and then you can convert it to the biomass based on the tree species and so on. And we have a tree quest which is focused on individual trees, so really measuring the volume of individual trees. And both apps are based on augmented reality and structure from motion. So it's basically photogrammetry is behind. So we reconstruct the scene based on images. This here, this quest here, it's Luxembourg Park. So this is a special quest we designed, and it's actually first time now. We are actually testing this now, first time for you guys and with you. So we designed the special quest. So we go out. So you will use this one, and we will measure the trees individually. Yeah, all together. And so all the measurements then arrive in the database. We have about 45 trees around, and already we have a reference for those trees. So you can actually get the feedback how your measurement is accurate. Yeah. If you don't have the app, those are the links where you can download it. So now it's the question. I don't know how I can share it on Discord. I have to do it manually, so I have to go out from the. Yeah, I don't have a Discord here. But I will share it in chat, and maybe somebody can copy from the chat to the Discord. Yeah. So, yeah. So but basically the GeoQuest, you have it, or if you have an Android, if you go to the Google Play, if you just type GeoQuest exactly like this, you will get the beta version, so you can install it. For iOS, you need a special. I'm not an iOS person, but I think there is a test flight. Yeah, there is a test flight. You need a test flight app, and once you install the test flight app, then you can just follow this link, and then you will install it on iPhone. Yeah. So. Yeah, you can do it now. You can do it a bit later. Doesn't matter. I think it's just a matter of a few minutes to get it. I will continue further with the presentation. This is just to explain. So when you download the app, and of course you should make your own. You should register. So with your login and. Yes, like password and username. Please take care that the username, there is an option to check if you would like to appear on a lead board. So we have a lead board who done the most measurements, the most accurate measurements. So if you want to appear there, and I actually encourage everybody to appear there, but you don't need to share your own name. You can make any kind of alias or whatever, and. But this is the point, that we all appear there, and then there will be some prizes for people who done the most accurate measurements. Yeah. So so please log in, and then when you select this Luxembourg Park trees option, you will get this windows. Here is explanation about the quest. So what is the aim? I have another slides where I can explain it much better. But it's basically about, we have 45 trees, and they shall be surveyed only once. And so here you can see in the next window how those trees are distributed. So this is our location now. So we are here. This is actually IIASA, and we will take this entry here and go around. So we have some trees here. We have some trees in this area and also in this area here. And so we will try to go around, do the measurements. But you are also welcome to go yourself later and do extra measurements as well. Yeah. So the measurements go. So you first have to select the tree you want to survey. So maybe tree numbers, this tree here. So you click it here, then you go close to the tree, approach about 1 meter, and then you start doing the measurements. And when you start doing the measurements, you get this kind of of the window. So you can see here the augmented reality elements inside. Here I selected the manual approach for measuring the diameter. So you see here the white line. So basically you align the white line on the left side of the tree, then you say next, then you align the vertical line to the right side of the tree, and then you say next. And then you immediately get this kind of circle fitted to the tree. So that then you've done this puzzle area measurement, and there is a second step to measure the height, and then you get a volume. And at the end there is a questionnaire. So you are also asked to fill in the questionnaire. Each tree has its own ID. So this ID, it's very important to enter, because this ID will help us to relate your measurement with the reference data. And then we will compare your measurement with the reference data. And based on your accuracy, you will get a score between 0 and 1. Yeah. So 1 means you measure exactly like terrestrial laser scanner. 0 means nobody will get a 0, but close to 0 means that your accuracy of measurement is very low. Yeah, and you cannot repeat it for this tree. You have to go to another tree and then try to improve the accuracy. A small tip: if you want to be accurate and collect more scores, use the manual. Yeah, the manual approach is more accurate than the auto. And also we have up to 4 measurements for the DBH. So we also ask people, like take 1 measurement from this side and just go 90 degrees and do the second measurement. Yeah, this helps a lot, because a lot of trees are not evenly shaped. So with more measurements, you account more on that. So you get a better. So, and you can do up to four measurements per tree. So I would say with 2 you will be on the safe side. With 3, maybe you need 3, maybe you don't. But with 3, maybe you lose more time. You have 45 trees, so you have to calculate. Yeah, what's your aim? Yeah, about the tree quest. So when you start the measurements, you have to gently shake the phone left and right. This is just to collect a bit more images from different angles. And because more images from different angles means better geometry to get those yellow points. Those are the feature points, 3D points that for which we have 3D coordinates already locally with respect to the local augmented reality system when it was initiated. And then in the next step, this is a very important thing. We have to select the reference point. Yeah, so because all our measurements are based on this reference point. So one of those feature points, so you will get this white cross. And when you place one of the feature points inside of the white cross, so you can just say next, and this point will be taken as a reference. So we do all our relative calculations based on that point. And this reference point should be usually at this height, 1.3 meter or something like that. That's the way how foresters, So. Yeah, I see Florian is happy with that. It's a diameter of the breast height. So DBH. That's the way how foresters measure. So we will try to mimic this as well. I think Giuseppe is also forester. So Giuseppe will have something to say. This is just some. So those are this automatic and manual mode. So if we go back, so you can see it here, you can select the automatic manual mode here. But basically the automatic mode means once you select the reference point, the app is immediately find out we have a kind of a vertical tolerance, and we select all the horizontal points within the a vertical tolerance band, and then we fit the circle through those points automatically. That's why it's automatic approach. The manual approach is like with this vertical line when you go left, right, and then we actually measure those vectors to the left and right, and with some simple geometry we can derive the radius from those measurements. This square here, I don't know where it's coming from, but yeah, from the late evening preparation of the slides. Yeah, and yeah, the next slide is about measuring the height, tree height. So I illustrated here up to the first living branch, but we will not do this today. So you have to measure up to the top of the tree. Yeah, and so all those DBH measurements, you should be about 1 meter, 1.5 meter close to the tree. But for height, yeah, I recommend you just step back, but please keep the tree in the image, you know, so just go back, take care, you know, don't fall, so like look back, and approximately at the distance of the tree, when you step back and you do the height measurement, that would be good, because we have a 45-degree limit. So if you measure the tree more than 45 degrees, it will not take the measurement, so you will get a warning. So yeah, and here you can see, first the bottom of the tree you can do while you are close to the tree, and the top, only for the top of the tree, you should step back. Yeah, and so we get those two vectors, basically based on the reference point in the background. We fit a vertical plane, and we take the intersection with the vertical plane and those vectors, and this is how we get the height of the tree. Yeah, this is about the trip. So we are here. We will use this gate here. So we go out with Sandra. Sandra has a key for the gate. So we go here around. We have some trees here in this patch of the forest. So you can see those are but those are very thick trees. If possible, I wouldn't start with this because they're a bit more demanding to measure. Yeah, they're actually the most demanding to measure, especially the height. And I would rather go and start from those trees here. The only problem is today there is a very important, high-profile politicians are just in the building next to us. So basically, this area is locked. I think they are either here or here. So yeah, we have to see if the security will let us going here, but yeah, I hope it will let us. If not, we will just turn and maybe just focus today on those trees, and maybe another day we go and try to survey other trees. Yeah, that's about this. This is the reference. This is a terrestrial laser scanning. So TU Vienna, we are collaborating with Vienna University of Technology. They came to us like a month ago, and we done the scanning of all those trees and segmentation. And they actually, TU Vienna has a very cool brand new algorithm for making a 3D models out of the trees. I mean, it's nothing new. There are many other algorithms, but they claim that they are now up to the model that is quite accurate. So we rely on that to get the reference data. And of course, Florian actually done and I was helping him to do like a manual measurement, so with the tape and the forestry instrument. So we have all those kind of reference data. Yeah, and at the end, when you do the measurements, you will appear on a lead board. So you can see the Florian is leading, he's the best. I'm the worst, I'm the last. Yeah, but those are just we just try some tests and so on. But we will have a leaderboard only for you at the hackathon, and the first three places will get a present for us. Yeah, so but we can wait till Friday. Yeah, so you can survey today, you can survey tomorrow, and maybe on Friday, and maybe on Friday before we finish the hackathon, we just look at the lead board, and then we will distribute the prizes. This is if you survey one tree, that's important to say. You are not allowed to survey it next one day. So you have to wait one day and then the next day go again. So this is just to stop you survey single tree 50 times and you are first on a lead board. So the aim is that you survey all trees. And when you survey all trees, maybe you can come back to and repeat the measurements for one of the trees you already done. That's it. I think I covered this all. And big thanks. So those are actually the guys behind the app. Florian is here, but Rudy, Tobias, Santosh, they done a really amazing job, and I'm really happy. I work with this great team, and I hope we will have a good test of the app today. It's the first time ever, so please be gentle. We are happy to receive the feedback, but please be aware that the app is really brand new. It's still not ready. In September we will announce it, and it's a free app. And all the data. So we have a web page. Let me just go to this web page. If I can open it. I don't see my mouse, but there is this web page where all the data arrive, so you can log in there, you can examine your data, you can see the reference data, you can download your data. So all the data we collect, they will be openly available as well. So, but with this I will close. I cannot show you the web page, I can show you later, but I think we can start slowly going to the gate, because we promised we will enter the gate at 2:00. Okay, thank you very much.